Okay, so tonight will be kind of a quick night. Anybody have any questions about anything so far before we jump into the material for tonight?
What did we go over Monday? What's that?
So Monday we were looking at lists and tuples and various types of collections.
Okay.
Or we say arrays. That's kind of an important one. Technically, we don't have arrays in Python, but that's our general catch-all term. Unless we're explicitly explaining what our program is doing, where we mention one of our other data structures, array is our generic catch-all term. Kind of like the way we say Google it rather than search for it. Or we say TiVo instead of DVR recorder. Array is the catch-all term, but we don't actually have arrays in Python. We have lists and tuples, which kind of leads into tonight's stuff because there's a very special type of collection of things that we use a lot in programming, and that's going to be strings. A very special thing, right? We've been using these since day one. Technically, a string is an array of characters. I'm putting quote marks around array because, again, we don't have arrays in Python, but that's our generic catch-all term when we're talking about collections or data that we've grouped into a single object to work with. So a collection of characters, which essentially means written language. So that's why it's a very important one gets its own ninth instead of just being tacked into the lecture on arrays or lists and tuples is what we have to work with in Python. Because written language is how humans have traditionally stored data. Like that's actually where we draw that line between history and prehistory, is when our ancestors invented writing and data could be stored. You know, we can pick up a book and read the words written by somebody who died hundreds of years ago. So the more traditional data storage, and so obviously it's going to be used a lot in programming, and we've been using it since day one, at least printing stuff out. But what we're going to look at tonight is manipulating it, working with them. Some of the functions we have to adjust it to fit our needs. So a couple notes here. In some languages, the double quotes, I'll spell it out. I was getting ready to make the symbols, but that's probably wouldn't show up so well on the board or on the video. So double quotes and single quotes are interchangeable. And you've probably noticed by now, Python is one of those languages. It doesn't matter whether we use double quotes and then write our string, or a single quote and then write our string. The only restriction is we have to close with the one we started with. If we open it with a single quote, we can't close it with a double quote. We have to close with a single quote, and we have to close the one we started with, otherwise they're interchangeable. And in the programming languages where they're not interchangeable, I'll just write it over here. So if not, then single quote marks mean a character, and double quote marks mean a string. So in Python, we don't have to worry about that, but in some languages, they are distinctly different. And you'll just want to be careful whether you're working with a single character or a string at that time, because the two things are processed differently. A character is typically primitive data. We haven't really talked about that because we don't have any primitive data in Python. Python is only object-oriented stuff. So when we say we have asked for an integer, we have a huge integer object, which we'll get to object-oriented stuff next week. But we don't have any primitive data. That's stuff you would have learned about in the SDEV 120 class, where where we'd store an integer, say like 29, in binary form. That what is that? No 128s, no 64s, no 32s, 16, 8's 24. So we need 5 more, 4, no 2s and 5. So we would store it just as those pure bits, or a capital A, just the character A, the ASCII code, which ASCII code happens to be the first 255 bits of Unicode, so we don't really use ASCII code anymore. Pretty much everything's Unicode anymore. So that would be number 65. So we would store that as no 128, a 64, and then we need one more. 32, 16, 8, 4, 2, 1. So those characters are primitive data. We can store that as one, represent that in like 1 byte, essentially. We work with much more than 1 byte at a time anymore, but whatever size we're working with, our primitive data is just that raw binary form. A string is something more. A string is a huge collection of those, no matter what language we're working in. And in Python, we don't have any primitive data. That's why we haven't really talked about that in this class. So at some point in the future, you might have to keep that in your mind. Keep that in the back of your mind for some point in the future in case you need it. If they're not interchangeable, single quote marks are 1 character, and double quote marks are for lots of characters at once. So we can interchange those, and we also saw, at least briefly, in Python, we have the doc strings, which is we open those with 3 sets of double quotes. Then we can do a bunch of stuff. And one of the big uses of those is the interpreter will ignore line breaks. So if we have a huge long string, we can put, we can just hit enter and carry it down to the next string. And then when the computer sees the doc string, it's going to know that is all just 1 string. It's going to ignore the line breaks. It has a special usage in Python that is beyond the scope of this course. Contains information for the computer. A little beyond the scope of this course. If anybody would like to know, you can ask me later and we'll talk about it. But it's background information. So really, unless you're rewriting the interpreter, you wouldn't need to worry about that use for it. Or customizing the interpreter. We've also talked about using that as multi-line comments. It works really, really well for that. You just want to be careful using doc strings for the multi-line comments. If we have a great big comment, because it is not a comment. When we put in our comment symbol, the computer completely ignores whatever's after that. It just sees the comment and then ignores the rest of that line. That's not exactly what happens with a doc string. If we use a doc string for a multi-line comment, the interpreter still reads it in, loads it into the CPU and everything, gets ready to process with it. It just doesn't do anything with it. So it gets deleted very shortly afterwards. But if you have lots of those, it will start to slow down the program. So you just want to be careful using those as multi-line comments. Several single line comments are better. I guess that's why they only put the single line comments in the language officially. And so, looking at strings tonight, and strings are objects. Everything in Python's an object, but for the stuff we're going to look at tonight, we need to kind of jump ahead and preview what we're going to look at next week. One of the things about objects, there are three main points to it. And one of the big things about object-oriented programming is this term encapsulation. Kind of like enclosed, thrown in a capsule and locked up, everything. And what we need from that term tonight is everything about the object is included in that object. All the behavior we need from a string is already included in a string. So that's what we're going to look at tonight, a bunch of methods that are already built into our string objects that help us manipulate it. And then we can have better control over that. So I'm going to erase this little symbol here. There's not really much going on with it because this next sentence I want to actually write down in really big capital letters. It's a very important one. By the college level, I assume everybody's familiar with with the English language, right? English is an awful mess. Right? I also do some tutoring, and one of the subjects I tutor is writing. And most languages in the world, people don't, once they reach the college level, don't need help with the language they've spoken since birth. But English is an awful mess, so that's still very, very common. That at college, a 22-year-old that has been speaking English for 21 years might still need some help on some of those complicated grammatical rules and just the awful mess that the English language is. There's a trade-off for it. That mess makes it so much more powerful. In most of those languages, people don't need help because there's one and only one way to say things. English, we have so many more options, and we can include that way from the other languages if we want. That's perfectly fine English. But I assume you're familiar with that. The point I wanted to make, and write really big here, in all caps, is never, I'll expand it, never, ever, ever have a program output grammar errors. I'm trying to use up all these little pieces of chalk I have here too. That is a very important, critical point. I'm going to write it in all capital letters, really big, circle it, draw some more arrows pointing at it. A program full of bugs that crashes constantly would not seem as buggy as a program that has a single grammatical error in an output. People will notice that. So that's a absolute critical thing. Always make sure your grammar is correct when you do the output lines. People will notice that very, very quickly. And then they will start to question everything about the program. Even if a program crashes, in the modern world, we're used to programs crashing on us occasionally. People are going to be like, oh, that was weird, and just start it back up and ignore the bug most of the time. But when they see a grammar error come up in like a dialog box, well, you'll have surely seen it, right? They're going to take a screenshot and stick that on Facebook immediately. Throw it on Twitter and make sure the world knows about a grammar error in your program. That way everybody can laugh at it, I guess. But a very critical thing, always make sure the output is grammatically correct. And that's part of the reason I do that programming essay, I guess Python essay in this class, is practice at that. Practice putting long strings together, it's a page-long essay that you have to program. So a whole lot of strings to control and manipulate. So it should be some good practice at that. The other thing, it's actually the very last point about these. I'm going to erase this little picture part here. That way I don't have to erase the whole board. That was just the doc strings. We've seen those 3 quote marks, and we can do a multi-line string. Strings are tuples. And we saw that the other day, list and tuples. Remember, lists, we can change. They're very dynamic. We can manipulate them in lots of different ways. Tuples are non-dynamic. Once we create it, that's what we have to work with. If we need to make changes, we have to make a slightly different copy in order to do any changes, which is one of the first things I had in mind for the example tonight. So mostly just a couple points about strings here. Across the board in language, all the languages, a string is always an array of characters. So if you forget some of the methods in different, if you go to work in a different language and maybe forget some of the methods or something, you can always treat it as an array to manipulate the thing. But a lot of that stuff is built in already. So we can use the built-in ones that people have already written for us. Does anybody have any questions about those general points?
No.
Okay, so mostly examples, because again, programming is an active subject. We learn by doing. I'm gonna go ahead and share my screen and walk through some of the things about strings. I'll go ahead and open idle. And I'm going to make the text bigger. I went back and made it smaller when I was grading stuff. How big was it the other day? Will you all be able to see that size okay? Idle doesn't have any sort of zoom feature, so I want to make sure it's kind of clear.
Yeah.
Nice big text on the screen. All right, that'll work. So the first thing, I'm going to start with what we've already seen. I'm just going to stick a string into a variable. I'm going to call it words. Here is a random string to work with. Just a quick example, and we've seen many times, once we have a string, we can just call our print method and print that out. So just storing a random set of words, a random collection of characters into this string called words, or this variable called words. Then I'm just going to print that variable out. So save this. Documents, delete. Oh, I thought I got rid of those things. I'm going to delete those other files because that was from this afternoon when I was getting ready for this evening, and I thought I took them out of there already. And that's going to be confusing if I have a bunch of files with the same name during the exam. Multiple files with the same name in there. Okay, so now that's saved, this we've seen before. Just kind of prints out those words. It's stored them in memory, but we can do stuff with them. We saw the other day, we talked about lists and tuples, and we can access things by an index number. So maybe we could print out words, I don't know, the fourth character, or actually index 4, the 5th character to the 9th character, which remember the last one is not included. So this is going to stop right before, this is a character 4, 5, 6, 7, and 8. So we can print out substrings just as an array. And this is one that works in every language. So I save that and run that again. You can see we got those characters there in the middle. So 0, 1, 2, 3, here's our 4th character, 5th, 6th, 7th, 8th, and then I said 9, but remember when we ask for something, when we refer to it by index, that is the index, we're asking for where those bits start at. So if we ask for index 9, it only goes to the very start of that in like a stack heap diagram. Where's my pen? So like if we have an array with a bunch of elements there, and each one has several bits in it, when we ask for the index, we're asking for the start of it. So if we say go from 4, say this is, well, yeah, so this is 0. If we say go from 0 to 2, we only go to where 2 starts, and we don't actually get the bits that make up the data for the second, for index number 2. So whenever we do that to from thing, remember that last one is not going to be included. But the first number we put in there will be. But this is like what we saw the other day. So I put up here strings or tuples, which means they are non-dynamic things. So we cannot assign stuff this way. I'll go ahead and throw that up there. Like words, words, character number 3, maybe. We meant to change that to an S. And then this one's going to throw an error in Python because it's a tuple, it's non-dynamic. So you see we get a type error, which y'all are probably getting used to seeing those now, right? Starting to make sense of how to read those messages. So it tells us directly, a string does not support assignment. So we can't directly assign them that way. But there is a built-in method we can use. I'm going to make a note here, a tuple, so cannot directly reassign, which is what we saw the other day. If we need to make a change to a tuple, we have to make a copy that is slightly different. And there's a built-in method we can use to do that. And that's going to be replace. So I'm going to do this 2 ways. Words.replace, and I'm going to replace that first one. Instead of saying here is a random string to work with, I'm going to say this is a random string to work with. I'm going to replace the word here with the word this. So if we need to replace part of the string, we just do the reference to the string, and then the dot, we'll see this more in object-oriented programming, the dot is saying something about that string. And strings have this method called replace built in. So we're going to replace any instance of the word here with the word this. And yeah, I'll go ahead and print this. And save that and run this, but you'll notice this time it didn't replace that word for us. Let me put this in a print string. I should close this to get to a new one. But notice when I said print words.replace, it changed here to this. But here, when I came back and just printed words again, it's still like it originally was. So we can't change the original. So if we do something like this, we need to reassign it. So I'll call it new words equals words dot replace here with this. So again, strings are not dynamic things. So if we need to make changes, we can either do it right in the print statement, or we need to save it to a new reference. Now when I run this, oh, whoops, I forgot to print that last one. Let me add another print statement in here. Print new words. I guess there's 2 steps to everything we're gonna do tonight. Got to make the changes and then print it. So you can see here, we actually saved those changes. So you just have to remember, you can't change a string directly. You have to change a copy of the string. That's sort of a protection issue. That way we don't lose our data from it. There's that. I'm gonna make some section marks. Here's a few things. So the next little section, let's look at the components of a string. So we can refer to bits and pieces of the string if we need to, kind of like we did here. But if we're going to refer to the index exactly, we need to know in advance what that index is, right? And sometimes that can, if our program gets a little complicated and it builds up the string along the way, we might not know when we're putting the original program together what index it is. So there are ways we can look for it. Is there an A in there? Yeah. Okay, so I'm going to just pick a random letter. I'm going to look for this A here. And I'm going to go ahead and store it. That way we can refer to it. And once again, anything, we could do this directly in a print statement or directly in a calculation when we're making copies. For all the examples tonight, anything we do, I'm just going to save into a new variable. But that's not a restriction. We could do it right in the print statement if we wanted to. So to look for something so that we can find it and access it like this way, we just need to know what index it is. And that is our key, the name of that method. So we'll do words.index of, say, a lowercase a. And on this print statement, I'll add some stuff in. The letter A first shows up at plus first A. And then that's an integer, so that needs to be cast into a string. So index just tells us where that letter starts at. Or, yeah, where the first place that letter shows up. So obviously, if you're looking for a bunch of cases, you probably want to set that up as a loop and kind of keep walking through it. I didn't realize my tablet was going to go to sleep on me. I have my notes here about this stuff is on there, and I apparently forgot to turn it off going to sleep. So yeah, we can put that in a loop and then walk all the way through the strings and find every place that an A shows up. But hopefully that's an easy expansion from what we've already seen, right? We know how to do loops. We know how to walk all the way through a loop. So the only new thing here is this index method. But that's only somewhat helpful, right? What's a good word to look for? String. Maybe I actually want to pull the word string out of that string. But what we've seen so far is going to find the first instance of that S shows up. As we go through here, S shows up before we get to the actual word we want. So another very useful method that's very similar is we call it certain word, is we have a find method. So we can do words.find, and then what are we looking for? We're going to look for the word string as well. And this will give us the index where that first shows up. So I'll put that in a sentence. Print, oops, that's not how to spell print. So print the word string show starts at index plus certain word, which is an integer, so I need to cast that. Which this is already filled up with words, so I need to start closing that every time because there's no clear button in idle. So you can see it tells us what index that word starts at, which makes it a little bit easier to narrow that down and work with it, right? And go through here and start at index 17, and we know string is string, 6 letters long, so we could go from 17 to 24. That way, because we need to include 23, and then we're back to that point that the last one, when we do that from to thing, will not be included. I'm just going to add some white space. Whoops, that's not my shift key. That's why. Scroll space. I don't like working at the very bottom of the editor. I like to have the cursor like around the middle. I prefer not to work at the bottom or top of the text file. So that gives us some ways to find those. But something that might be even more useful is all of this stuff is about splitting it up, dealing with it one character at a time. But we all speak English. English is a spoken language, and writing these characters out is just a representation of it. When we say the word random, for example here, do we stop and think about the letters used to spell that word out in most cases? Probably not, right? Is we think about the word, and then these letters are just a representation of the word. So another really useful one for components of it is we can automatically split that up into a list of words. So I'll store that here, word list. And again, it's built into the string method because that's a common property or behavior that we're going to need. So all the behaviors are already encapsulated in strings. And we can just say words.split and call the method. We don't have to pass anything in. And then if we print that word list out, and run this, I'm going to close this. So just the name of our string dot split, and then we'll print that out. You can see we have a list of the words rather than every individual character. And that can be a lot more intuitive to work with. Then we can think about it as far as the words in the sentence rather than each individual thing. And something I haven't shown yet, any thoughts on this. So I was saving these all the variables. And then whenever I was calling these methods about strings, I was putting that on the variable name. What do you think would happen if we put that directly onto a string? That might not be the best way to ask the question. Example string not stored in a variable. But then we have this dot split method. Do y'all have any thoughts about what might happen when I run this? Think that's going to give us an error, or will it work?
Maybe an error.
The best way to learn is to check, right?
Yeah.
That's why I like to do this in the class, right? If we're curious about it, we can just check and see if it works. Oh, I forgot to save. So save that, and now we run it. And you can see it split it up just like the last one. So the reference, where was the original string? Oh, up here. So putting this to a variable name is just for our benefit. It makes it easier to code. It will behave exactly the same if we just did that directly onto the string. But it does seem like something that would throw an error. So that's why sometimes you just have to try stuff and see what happens. There's word list. Here's number. That's an important one. So I'm just going to show one of these, then refer to a table. Check type of data. Table 8-1 in textbook. I have in my notes the page it was on in version 3, and I've just now realized that page number is wrote down in version 3, so it's probably not correct for version 5. But it is still table 8-1. My textbook is upstairs in my library, so I can't quickly check here. But somewhere in chapter 8, near the beginning, there's a table that has ways to check our data. So I'm gonna make up a couple strings here. So I'll call num1. I'll make that the string 5. And num2 is the string 5, the digit 5 as a string. So only one of those is actually a number, right? Because maybe we have an input prompt. We're asking the user, enter a number. Can we really trust the user to give us this and not this? It's hard to say, right? So we need to be able to check for that. And that is, we do that with another built-in method to the string, which is a very important topic that we'll see next week when we get to object-oriented stuff, the encapsulation. All the behaviors we expect a string to have are already included in strings. So we can do this check. So if num1 dot is numeric, and that is a method that returns true or false. So whenever we have the methods that return Booleans, putting them right in the if block like that or right in a while loop is the same as typing a condition. A lot of people, when starting out, would prefer to say if that is equal to true. But if you remember when we went over selection structures, if only does stuff if things are true. So this method right here is either going to say true or false. So we don't necessarily have to do the equal to true, but some people, especially first starting out, find that a little bit easier to keep track of. So if that is a number, then we'll print what is it? String num1, whatever it is, cast into a string plus is a number. And if it's not a number, print the same thing. I guess I could copy and paste it. Print those same words, only with a not in there. Is not a number. And then we can check the other one. And that just helps to confirm that what we have is what we think it should be. Right? If for that like simple example I just used, just because we ask the user for a number doesn't necessarily mean they're going to type the digit 5. They might try to type a word or something. There's no telling what people might do. So we have to kind of protect against it. Make sure we have a number before we do math with it. Because something like this would definitely be a problem, right? That's definitely going to crash the program. So we want to make sure what we have is a number. Or like all this casting stuff. Before we concatenate things into a string, we want to make sure they're a string. And that's what's on table 8.1 is a whole bunch of type checks. Probably should have brought the book down, but we can check and see if things are, is alphanumeric, is it a letter or a number? And there's different checks. It's the table has the most common ones. And we can do the same thing for the second number. Is numeric, and this was mentioned briefly. A whole lot of the built-in stuff, the original stuff in Python was written in juxtaposition case. So all lowercase letters and multiple words just slammed together, which is really the same thing. I can just copy this and change those 1s to 2s. Paste that in, and number 2. So even though it is in quote marks here, the computer should still recognize that that digit is something that we could do math with. We have to cast it into an integer before we do math, but it is a numeric type of data. So that is an important one. You always want to check that, especially when getting input from a user. Make sure you have the right kind of numbers or right type of data. Might not necessarily be numbers we want. We might want to know booleans. So there's our output from that. So the word 5 is not a number, but the digit 5 is a number. All that making sense so far?
Yes.
And another one that kind of goes along with what I was just saying about checking and confirming user input. This one is incredibly useful for user input. Is actually it showed up on homework the second week. Y'all remember that Wi-Fi troubleshooting program where asking yes or no questions? Those are short words, right? 3 letters in one of them, 2 letters in the other. There are 6 people in this class, and I don't think any 2 of you all used the same yes or no on it. And some people it was spelled out. Some people it was just a Y or an N. Some people it was all caps. Some people it was all lowercase. There's a lot of different ways we could ask just for the words yes or no, right? So of all the different things that can be typed, that the user could type in, we'd have to put or a whole lot of places to check for just different capitalization on words. So one thing that is really useful to before we check user input is go ahead and change it all to the same case. So I'm going to make another string here. Here is a randomly cased string. Right? We can't really say our users aren't going to type something like that for some weird reason. Maybe while they're typing, hardly paying attention, there's a cat over there trying, their pet cat is sitting there trying to join them and swatting at the keyboard and keeps hitting the shift key. And the cat's being all quiet and they don't quite notice the cat's hitting the shift key and aren't paying attention to what they're typing to get something like that. Or maybe a soda was spilt on the soda or some coffee was spilt on the shift key and keeps affecting the capacitance in the key so that the shift key keeps triggering and changing the case. So we can just change that. So first off, I'm going to print that line, print out stuff, and then another built-in method, because we want to encapsulate everything about strings. That way they're ready to work with, is we could just make it all uppercase. And these are methods, so make sure you put parentheses. I like to think of that as parentheses are sort of the standard notation for do something. Without parentheses, that's a variable. So no parentheses means store something. With parentheses means do something. Just like the quote marks are the standard symbol for exactly these words. So no quote marks means a variable, and quote marks means a string. A method, parentheses means we have a method. No parentheses means we have a variable. And just like uppercase, we could also just change it to lowercase. And that's very easy to put into a condition, right? Because then no matter what the user types in, what the user gives us, we can say like user input dot lower equals what we're looking for. So no matter how they type the word yes, we can just check it against lowercase letters. And then we don't have to do a whole bunch of or situations to check for all the different ways that they could change the case in a string. Uh-oh. Oh, whoops. Sorry, I was talking and typing at the same time. We don't need case in there. It is just upper and lower. I was saying case. I did not mean to type case. Yeah, so stuff dot upper gives us all uppercase, and stuff dot lower gives us all lowercase, which is incredibly useful for, again, checking the input users give us. Also, it just passed through my mind, so I want to make sure and explicitly state it. It happened a couple times on the homework from last week with reading files. A file name is always a string, and that is across the board in computing. It doesn't matter if you're scripting up instructions for your a Cisco server on iOS, Cisco iOS to look for a file, or any type of server, a PC, a Mac. A file name is always a string everywhere in computing. A string is an array of characters. It's basically written language. So anytime we want to store data, we store data in a file named with characters humans will recognize. So it showed up in a couple people's homework. I can't remember who all's homework that threw errors on, but yeah, just anywhere in computer, if you're doing stuff on a computer, a file name will always be a string. Sometimes we can get around that. There are places that it's obvious we're going to be giving it a file name, so we don't have to put the quote marks in directly. But in those places, it doesn't hurt to put the quote marks in. So it's just something my computers remember, and I think I forgot to explicitly state that last week, so I wanted to say it here. So hopefully all that's making sense. You can see how we can get a lot more control over our strings instead of just putting them together and printing them out using the print method like we've seen. The last thing I want to look at here is sort of like template strings. I guess that's not the only use for them. I've seen this, several people have been using the printf method and using a variant of what we're getting ready to look at. So here's the stripped down version of that. I'm just going to make a string called info, kind of like that. Whoops, I meant to call that intro. So I'm going to make a string called intro. I guess info would have worked. And put something like my name is, and well, if it was me, I could type my name, type Chris right in there, right? But I want to generalize this so that this sentence works for other people. And I don't know what name is going to be stored there. Maybe it's in a database and we're going to grab the names later. So we can just leave placeholders in there with curly braces. So we put in the curly braces, and I am 5 years old. So there's sort of a template string that we can fill in. We just left some placeholders here, just some completely empty spots. And now, then we go grab the data. Well, I'm typing this. I'm going to put my name and age in here. Age is 42. And this is another nice thing about this. So now when I go to print this, I can do intro, but I want to format that. And when I format that, I'm going to pass in name and age. So it goes in order. So whatever's stored in that name variable will get stuck in the first place. Whatever's stored in the age variable will get stuck in the second place there. And then we're going to come back and look at one more variance on this. But it just gives us a general template. So then we could, a sentence where everybody in the database, for the report, it's going to stay their data in the same way. We can just write that once and then loop through and feed in the data afterwards. So there's the name variable and the age variable. And notice I didn't have to cast it doing it that way. Because every other time we've tried to take an integer and concatenate it into a string or put that in there, except for that one special case of the print method in Python, where we use commas and pass in everything separately, we've had to cast our number. If we're filling in a placeholder, we don't have to cast the data. And just a slight variance on that, which is essentially the same thing. I can't think of a good name. I'm going to call this about. So the first one, that's like a sentence, somebody introducing themselves. So I call that intro. But if somebody else was talking about you, they would say that differently, right? So like then we'll fill in the age variable, but this time I'm going to give it a number. I'm going to put a number there. A placeholder, a placeholder year old named, then another placeholder with a 0. And I forgot my quote marks. So see how we still just putting placeholders in there, we just gave them numbers. And remember in Python, we start counting at 0. So the first variable we pass in will get put to the 0 spot. And the second one will go in the first spot. And print about, again, the format method, and the first thing we pass in will go in the placeholder we indexed as 0, and the second one will go in the index the placeholder we indexed as number 1. And then that one can also be very useful if we wanted to expand it. So in that sentence, then put the name in there again. Is in, oh. So I only had a couple of variables. So I'll just turn that sentence around to see how we can use them more than once that way. We know this variable is going to show up in several spots in that string. So we can just index the placeholders and then it will put them in as needed. Which is way down at the bottom of the screen, but hopefully you can see that. And then they're showing up several places, so we don't have to worry about the order for them. We give it indexes. I guess we do have to worry about the order because our order has to match that index on the string. So was that everything I had here? Yep. So any questions about that? It's definitely something that you're going to want to sit down and do. So tonight's lecture is going to be a little shorter than normal. That way there's plenty of time this evening to sit down and just manipulate strings. Just mess around with those functions and manipulate strings. And the textbook has some stuff. I did refer exactly to table 8.1, so you'll check that. But I believe I've mentioned before, I should probably mention this every time. Python is one of our server-side scripting languages, which means it's a standard for websites. So the best place to look for information about a standard for websites is going to be on the W3 School site. So you can just search strings in Python and look for the W3 School site. Has everybody seen W3 Schools before?
No.
That funky site that can be a little infuriating at times because they set the standards, but their website is not written with those standards. It's always a little aggravating. They have and their website is written in C# with ASP. So it runs on a Microsoft server. It's a .asp file, not the standard that they're talking about. That always seems really odd. But here's they have an excellent breakdown of the strings and examples, and they have that try it yourself editors where you can go through and type right in there a bunch of different things about strings. Oh, I just saw one I probably should have mentioned, length. We saw length with arrays the other day. The LEN method tells us how long a string is, or how long any collection we have is, how long an array is, how long a tuple is. So it applies to strings as well, if we want to know how many characters it is. There's a whole lot of methods there, examples there, and this is Python is one of the standards on server-side scripting, so it does fit into the HTML5 standards page. Our special characters, we've seen new lines. I'm pretty sure we've seen those. Just type \n anytime you need a line break. Carriage return is like a new line, only slightly different. For 99% of the uses, we could interchange carriage return and new line. \b if we want to actually use backspace and take characters away. The big thing is notice that we're using backslash for special characters. So anytime we need to escape out of any symbol that has meaning, we need to, we can't put it directly in the code, right? Like the backslash here. Backslash means something. So in order to type, if we want to actually type a backslash, we have to put the backslash in to escape out of the coding and actually put that character in. Same thing, if we want a quote mark, we need the backslash to escape out of the code and actually say that quote mark, not what that quote mark means in the code. those are called escape sequences. And here is the exhaustive list of everything built into strings down at the bottom of this page. You see there's a few more than we looked at, but again, it's an active subject. The best way to learn is to sit down and just do stuff. And you want to check the W3 Schools site. They're, like everywhere, they're an excellent reference. But there's no shortage of reference material out there, right? We have our textbook. Then W3 Schools should be the first place you look, but Google is full of reference material. Because that's a common project on your way through school. If you ever need to think of a project that you're not sure what to do, make reference material. A lot of people do that because then you're reinforcing all those skills, right? So like to practice with Python, write a Python script, or with Python strings, write a Python script that outputs a bunch of reference material about Python strings. And it like double enforces those skills. So it's a very common one in that the web is full of those. So if you ever need a project for like, website development, those show up a lot. Right? That's a standard class that people at colleges everywhere are going to take and have to do a final project. If they're not sure what to do, then a website that is reference material for HTML and CSS and for making a reference material for making a website doubles up the reinforcement on the material. So it's always a good project. But any questions about strings before we look at this other thing I wanted to show really quickly because the book doesn't mention it?
No.
Okay. So the other thing I wanted to cover tonight, because the book does not mention it, well, once again, I forgot where the address is, so I got to go in. There's too many files on the computer to remember where some stuff is located, so I need to get the address for Python here. Python, I'm going to open. I'm just going to copy the address from there. And we kind of talked about this before. When we were writing modules, remember the Python, all those things we import are just modules that people have already written, things that can be used. What's ABC? Let's open this. Let's see. Sublime. Open it with Sublime. There's lots of text editors, so that's another thing. Make sure you try different text editors. Find some you like. This is Sublime. It's been a very popular one for a while. And you can see that this library is just a function that somebody set up. They put a doc string describing what it is and then what it actually does. Oh, I probably could have picked a simpler one that would have stuff y'all would recognize. CSV. We actually looked at this library. Now that we've seen list, instead of writing your data to a basic text file like all the homework was last week, I'll open that with Sublime again. Instead of writing to a text file, a CSV file, a comma-separated variable file, is much more organized and is still in human readable form. So after the classes, you can see it's just a bunch of methods that somebody wrote up that can be reused. There's some other stuff, we'll know those other keywords before long. But these are just large files of things people have written that can be used. And, well, my folder is probably not exactly the default one right now, but when you installed that, there was a whole lot of modules there. And then these other folders up here that are just full of more modules filled with methods and objects that people have wrote that we can use just by saying import whatever the name of the module is, like import SQLite 3 or import calendar or import JSON, import encoder, import decoder to work with JSON objects. And all that stuff, we can do that. But this definitely isn't all of them that have been written, right? Obviously, there's going to be a lot more than just those default ones. So when we bring, at some point, we're going to want to bring in more libraries to work with. For example, video games are very popular, right? And it can be a lot of fun to write video games. I have a lot of fun with that. So what about if we want to write games in Python, there's this module called Pygame. This one's been around for a long time. It's very powerful. It's an open source project. It's been building up. Lots of people around the world have been building this for a long time. So they're on their site. Of this getting started one. Oh, and actually, this right here is what we're getting ready to look at. How do we install these modules? If you just go to pygame.org and then under docs, there's lots of tutorials and stuff to get started. It's really easy to get started with and start making games. It can be a little more fun than, say, parsing through a string. But here's a game engine. The standard, this is, it's not included in the standard install, but this is the official game engine of the Python language. So maybe we want to install that. So let's look at how we do that. I'm going to do it in PowerShell, but I'm going to do it with command prompt instructions. So I think next week, maybe the week after, when I pulled this set of notes out of the folder, it was the very next set of notes. So I think next week, but we might talk about objects first. We're going to do PowerShell really quick because we've now seen all of the parts that main parts we're looking at in Python this semester. And we stretched that out over 4 weeks, right? Spent a lot of time talking about selection structures and a whole bunch of time talking about loops. And we see how those pieces go together in one language. So I think next week we're going to come through and see those same pieces in another language in like half an hour. Because we know what they do, so all we need to see is the different syntax. So that's why I'm doing this here instead of command prompt. But if you weren't familiar with it, PowerShell is updated command prompt. So the old command prompt instructions work in PowerShell. They didn't delete any of them. They just added new stuff in. So all the old stuff works directly here. But if we went to install a method, there's this built-in module called pip. So I'm going to write it like this. It's actually abbreviated in PowerShell. I'm going to write the command prompt one. So we saw before on our command prompt or in PowerShell, we put in Python to access things about Python. And one of the keywords is -m. And that refers to module. I guess it's not a keyword, key letter, key term, key instruction, something. It was abbreviated along the way. But the Python, and then we want a particular module, and to install stuff is pip. So we're going to tell it to look at the Python programming language and look at the module called pip. So I'm just going to hit enter. And it pulls up all these instructions. Tells us how to write stuff in pip. So it's saying it should look like this. We type pip, and then we type a command, and then the options we want for that command. And then they spelled out the list here nicely for us. The commands we can do are going to be install, that's one we're getting ready to look, install and uninstall. which is essentially the same as copying and pasting that go online, download the module we don't have in our library, copy and paste it into those folders, and then update all our registries so that the language itself knows about it. So it's a whole lot easier just to do it this way, and then it'll do that copy, paste, and update the registries automatically. So we can just say, install whatever new module we want, whatever package we want. Or we can just download it and install it later. Uninstall, y'all can see the list there. The big ones we need are going to be install and uninstall. And then we have some other options. So like -V is the command prompt instruction, or the updated PowerShell version is --verbose, which just means print out every step so that we can see what it is. Or like --log, and then some file path would write a log of all those steps from downloading it to get those. So if we just type Python -m pip in the command prompt, we can get these instructions. Or in PowerShell, they went ahead and recognized some of the internal modules, so we could just type pip and get directly to pip without having to say it's part of Python. But some people like to use the old command prompts. If you haven't, go look at PowerShell. And all the old command prompt stuff does work in PowerShell. That confused a lot of people when they got rid of that button on Windows. We used to be able to like go to whatever thing we were in. We could hold Shift, right click. Whoops. We have to be on empty space. I'll go back to my delete folder. Put your mouse over empty space and push Shift, right click. And there used to be a shortcut to open the command prompt in this directory. And then Windows got rid of that and replaced it with Open PowerShell window here. And it confused a whole lot of people at first because they didn't know that PowerShell does accept the old terms. They didn't delete anything, they just upgraded it. They added stuff to it. So all the old stuff works there as well if you know the old command prompt terms. And we're going to look at PowerShell next week and see all the stuff we've seen in Python in like 30 or 45 minutes. Like just the syntax. What's the syntax for an if structure, the syntax for variables, and a couple of these things, so that you can see how the concepts we've been talking about apply in no matter what language we're working in. But we have this thing, pip. So I'll do the old command prompt one. So Python language, we want a module called pip, and then install that one I just looked at, Pygames. So just type that in, and I uninstalled this right before class, so it's probably going to load from the cache on mine. When we hit enter, yeah, it used the one. It used the cache one. Instead of saying the using cache here, if you do this for the first time, you'll see a little meter that fills up while it downloads it. Then it'll do the rest of this stuff. Oh, I need to upgrade pip, which is another thing we would do with pip. One of our instructions is to update and keep the newest versions of the modules around. So we would use pip to download the latest version of that, but I'll do that later. So now, when we go back to that Python module, is it in the folders? I don't see it in the folders. I was just looking for that library, but I guess there's a lot of places it could have ended up. Is it in your collections? Nope. I'll search for it. I know it's somewhere in here now. So I'll just search for it. There we go. So here is all the stuff with Pygame. So here's that that new package I just downloaded. A whole bunch of modules that we can use for a game engine to put games together. And there's lots and lots of things to use. So that's how, anytime you have a new module to work with, you'll just use pip to install it, which is on your machine. That is part of the basic. That's one of the basic core components of Python. So you should already have pip on there with when you install Python. If you need a new module, you can just install that. So I'm going to do another example. Is PyAutoGUI on here? So it's got to be in one of these folders. Well, I'm pretty sure it's on here. I'm going to uninstall it and reinstall it. And to uninstall it is kind of the same thing. We just ask for a pip command and just put uninstall. And I'm going to look at this one, PyAutoGUI, for an example. So the same way we installed it, just hit pip uninstall. It'll find all of these, kind of say where they are. Oh, site packages. That's probably where it put the thing to. So it's site packages. Yeah, so here's where it put that Pygame. And then this one, so PyAutoGUI. We're going to look at this one just here in a second because it's a really useful one. So yes, uninstall that. Then I come over here and kind of refresh this page, or leave and come back into the folder. You can see that's no longer there, the PyAutoGUI. And what this is it key bindings, replaces keyboard and my mouse functions. And again, anytime you're wondering about some of the stuff, you can just search for it. So like PyAutoGUI and then check the official documentation. This kind of explains all about it. All of these pages will have the information reminding you about how to use pip to install it. And then this thing has like mouse functions. Well, things about the screen. Oh, here we go. So we can like move to some location or move relative to a current spot. Yeah, so like drag stuff around, like relative to where we were, click in different spots. So it can be very useful for writing macros. So I'm going to go ahead and reinstall that. So we just ask for pip, then install the name of the package we want to get. And if Python knows about it, if it's already been included as part of the official language, which after you look into some documentation, you'll learn how to spot because the official icon will be on the page. Other people have cheap copies of the icon. there's a slight difference in, there's a documentation generator. We looked at those that you have to be approved from the Python programming language in order to use that official documentation generator. So one thing to look at is just that the documentation has that official look to it. But again, just ask for pip and then install whichever module. Oh, and normally it looks like this. We get a little meter, then it reads in all the things. And once it's finished, it just goes back to the little prompt there. And like this, will it reload that? Yeah, so now you can see it put it right back into those libraries over there on the hard drive where all the Python stuff is stored. And if you're in the command prompt, you can also check that same way we just looked for pip. So we can say Python programming language, go into modules, and look for, I'll go with Pygame first, that first one we installed. And I like to recommend that. A lot of people are gamers, and next week we'll be getting into object-oriented programming. And I think doing stuff with games is very helpful for understanding object-oriented programming. So we'll talk about that when we get to objects. So we get this little message from the module, some sort of default message, or it's going to do something. So that second one I did, if I do Python -m to say open this module for Pi Auto GUI, well, the default seems to show up some numbers there, right? An X value, a Y value, and an RGB value. And as I move the mouse around, you can quickly tell what those numbers are, right? It tells our mouse position and the color of the screen that we're above. So I'm going to grab a couple of numbers from here and go through an example of this, and then that'll be it for tonight. So I think for a quick example, I'm going to write a macro that comes down here, opens the soft keyboard, and well, like one method, when we call it the first time, it'll come down and open the soft keyboard, and when we call it again, it'll come over here and close it. That seems an easy little macro, right? Because all we have to do is move our mouse to this spot of the screen and click, and the exact pixels on your screen might be a little bit different. So make sure you took note of how I did that. I just put the Python command and said to look at the Pi Auto GUI module. -m means this module, then that module, and then by default, this one gives the screen mouse positions on the screen because we probably need those in order to do that. And this will, you can replace all of the standard inputs with this, the keyboard, the mouse, all of that. It has all those functions built in. Y'all can look at the documentation. I was just going to do an easy macro. So the center of that icon looks like it's right about here. I'm going to grab some paper and jot those notes down. Jot those numbers down. So like 12, 27, 749 is the position for that. And then after it's open, the close button looks like it'll be at 1273, 468. So for a simple macro, we could just set something up to go click at those spots on the screen. Let's see. I like to look at different text editors too. We've done lots of stuff in idle, right? Most everything's been in idle. Earlier, I opened Sublime, so you got to kind of saw what that looked like. A dark screen, a bunch of tabs. There are lots of different text editors, and you want to maybe try a few out and see what text editors you like to work with. Idle is definitely not the best text editor to work with. It's very, there's not a lot of features there. This one will work. It's labeled over here, but this Atom. This has become an immensely popular text editor for programmers over the past few years, and with good reason. It's a very powerful one. I mean, it's really a text editor. There's not that much difference between them. But you want to try a few different ones out and see what sort of text editor you like. I'll use this to write our Python code tonight. So go to File, a new file, and again, just a basic text editor, the things we've seen. So we need that library we just imported, the PyAutoGUI. So obviously we could import PyAutoGUI, and this we're going to use a lot, right? We're going to say PyAutoGUI.move to, PyAutoGUI.click, just to get a basic macro. So I think I'm going to import this one the other way, because it's going to be used a lot, and say from PyAutoGUI import everything. And that way I don't have to keep typing the name of the module. I just imported it as part of the basic thing for the project. And I think I might do some delays. So I'm also going to import time module, and I will do it differently, just as a reminder that we have multiple ways to import things. I think the book really likes this one, but if we do it this way, we don't have to type the name of the module every time. And that looks like a complicated thing to type. So I'm just going to write a function that toggles on and off. I'll start putting pseudocode here. So toggle on and off the soft keyboard. So my first thought is we'll need a Boolean to track the state. Function if else on Boolean, and call those functions. So there's a pseudocode for it. Does that pseudocode make sense? Just have a Boolean saying whether it's showing or not. And then our function really just needs to be an if statement. Like if that variable says it's on, we turn it off. If the variable says it's off, we turn it on. And the difference is that we need to click in those particular spots. So to turn it on, we have to click right here, because this is something that's, when Windows made that, they designed it to go right here. If we ask to open this piece of software, that's the reason this one was on my mind. If we just say, run this program, start this program, all it does is put it in the taskbar. The only way to actually see the keyboard is to click on that button. So technically opening the program leaves it down here in our taskbar and is still a step short of opening it. That's why I wanted to write this. So need a Boolean. Is keyboard on? Which will probably start off as false, right? Oh, and I need to save this because there's no color changing or anything, and we do have a .py file. So Control S is save everywhere, but you can just try different. Whoops, that's not right. File. I forgot the extension. Save as keyboard.py. We just have to say what type of file it is. So now it knows it's a Python file. It recognizes those words, right? From and import and false and define. So we're going to define a function. I'll just call it toggle keyboard. And we don't need to pass anything in or out. But we have this global scope variable, this Boolean, keeping track of whether it's on or off. So we'll need to access and change that. So remember, with functions, we can access global variables, But if we want to change them, we have to actually put in the keyword global. Is keyboard on. And did you notice how the prediction thing came up a whole lot quicker in Atom than what it does in idle? That predictive text can be very helpful. So we're going to use that, and all we really need to do is check it. So if is keyboard on is true, then close it. If it's open, close it. Else, open it. So just kind of working in the pseudocode along the way. Probably get rid of that part of the pseudocode because that variable is there now. And this is what I'm doing right now. And then to open it, what we had to do is come down here and click on this button. Because if we went through the normal way of opening software and just said start or execute or any of those normal ways, all it does is put this button for the soft keyboard in the taskbar. We can't actually see it at that point. So to open it, we have to actually click on it. That's why I've imported this module, PyAutoGUI. And then from that, we can control the mouse in the code. So we can say move to, and then those coordinates, 1227, 749. 749. And then if we want to, it'll jump there instantly. If we want to, the third argument, we can pass in a number of seconds to take. So this is saying move to this spot on the screen and take 2 seconds to get there. So now if I call that, I call it toggle keyboard. I'll just go ahead and call that method and then go over here to run it. Oh, something crashed. I guess I have to run it from here. So I can see that error message. Oops. Change your working directory. Documents/delete. And Python keyboard.py. Oh, that's the text editor. Move to, where's the other numbers? 1273. Okay, so that might have seemed odd. Did you all see what the little error was there? There was nothing in the if block. So it knows that after the keyword if, there should be an indented line for everything we do if that condition is true. In this case, if that variable is holding the value true. But there was nothing in that if block, so it just noticed that the very next line was not indented. It didn't bother to check whether that line was the next hat, was the else or not. It just noticed there was no indentation. Now can I run that normally? I just go run that script. You can see the mouse moves down right to that button. So as soon as that ran, just move down there. We wouldn't actually click that button. So once it's in the spot, I'll click on it. And then I will set that variable is keyboard on. We'll toggle over to true. So save that, and where'd my little thing go? I need to move that someplace easier to click on. I'll put it over here. So run the script again, and from wherever the mouse is, it's going to move to that spot on the keyboard and click on it to open that up. And might as well do a close thing while we're at it. Because to close it, we have to click the little X, which, because of the lack of indenting after the if statement, the if line there, I had to go ahead and put those numbers in, but again, I'll just move to that position. And then I'll click. We might need to double click here. Nothing that we've actually done here has given that keyboard focus. So saying click once might not actually close it. We'll give it a try. And then toggle that variable to say it's off. So I'll just write that in the script, and that's why I imported the time module. So to put a delay, to say time.sleep for, I don't know, 0.75, 3/4 of a second. Toggle keyboard again. Yeah, that'll work. And I could put, I'm going to delay, put another delay. So time, the time module dot sleep, anytime you need a delay, and then you pass in the number of seconds or some floating point version of seconds. So 750 milliseconds there, I guess is what that's saying. 3/4 of a second. Then it'll toggle the keyboard, which starts off, so it'll turn it on the first time, wait 3/4 of a second, then it'll move to the X button, to the close button, and click. We might need to double click in this case. I'm going to save that and run the script. So it moves down there and clicks, but we haven't actually given the keyboard focus yet. Yeah, so we need to click twice there. The first click only gives the keyboard focus. All we did was open it, but then afterwards we have to do something so that we're on it. So I'll just click twice. I think there is an option where we can pass in 2 and say click and then like clicks equals 2 or something. There we go. Just a little script to open and close that keyboard and kind of show the different modules. Does everything there make sense? The logic on that? That can be an incredibly useful library. So I will send out these examples after class. The main thing I wanted to look at was that the pip used to bring in new modules. So if you find something online that has some pre-built functions that you would like to use, this is how you add them to what your version of Python knows. You just really it's a fancy, it's copy, paste, update the registry, but this will, if you do it this way, it does all that for you automatically, puts it in the right spot, updates the registry accurately, make sure you're getting the latest, newest version and all that stuff. So it's a really good idea to do this. And you can just ask for the instructions right in command prompt. You say Python, look at the module for pip, and then the default for that module is the instructions on how to use it. And that's how we import new modules into Python. And then I just wanted to show this one because that makes macros very easy. That library has all the typing functions to type things in, so you can automatically, fill out forms. If you know where the stuff is on the form, you can just automate the process of navigating around the form and filling it in. Or things where you're going to click in the same spot over and over and over again. You can just set them up that way. But you all can check the documentation on that. Just Google PyAutoGUI. And what time is it? 7:41. So that was everything I had on the list for this evening. Oh. I had another thing if that seemed to run short on time. But does anybody have any questions about that stuff from tonight?
No, but like I was using Notepad++ for
Mhm.
that PowerShell thing, and I named it like .py, and all the color looks right and everything for the Python language. But for some reason, whenever I do the colon and hit enter, it doesn't indent right for some reason. I'm not
Oh,
sure.
for Notepad++, you have to manually indent.
Okay. Let's see.
Yeah. So there's different things, and that's the things you want to try on different keyboards. So let me share my screen. Yeah, that's the one I tend to default to. The main reason I default to it is because Notepad++ is the only one that has this button right here. So all the times I've taught programming in a classroom and then projecting examples on the board, having a zoom is really, really nice, which has kind of got me used to that. But yeah, if we have save it with a .py. So any of our key terms, so if we say while and then true, I'll just write an infinite loop, just basic infinite loop, it doesn't automatically indent it. Whereas some of our other text editors, so Atom is immensely popular. Sublime has been growing in popularity over the past few years too. And I've kind of started liking it. So if we save this one the same way, hit save, am I in the right place? Nope. Go to documents, delete, something.py, and I'll do the same example. So while true, just an infinite loop, so both of these will automatically indent it, Atom or Sublime, but it's different text editor to text editor. So you just want to try several out and see which ones you like. Some of them will automatically indent it, and some of them will not. If you just really like Notepad++, we also have full control over this. It's under files. Oops. Oh, under language. Oh, maybe it's settings. Oh, there it is. Under settings and preferences, we can go in here and control what that does. Editing. Well, I don't see where it's at. Maybe it is under language. Under language and open user-defined languages. Oh yeah, it's in XML. We haven't seen any XML. I thought there was a little window for it. I think there's a window for it, but we can specify that when we write things in Python, it would automatically indent. So you also have full control over what your text editor is going to do. So I guess really trying different ones is really just amounts to seeing which one has the default values you like. But yeah, Notepad++ and another popular one, it might be brackets. You have to manually indent in Python. And the reason they do that, because some of your other languages will automatically indent, but in Python, we can use either the tab or push space like 5 times, right? It'll work the same, but we have to be consistent. So some of the text editors turned off the default indenting in Python. That way the programmer could do it whichever way they wanted. It wasn't like an oversight or anything. That was an intentional choice put there for Python. So Notepad++ isn't the only one that does that. Was that the only question you had, Jerry?
Yeah. Mm-hmm.
All right. So yeah, that was pretty much all I had on the list for tonight. That way it's mostly lab time. And as normal, my computer is going to sit here in front of the board with the lights on until 10 o'clock. So if y'all have any questions, we can jump back, send me a message. Anything through text messages or through Ivy Learn automatically goes to my phone. So we can jump back on here and address questions in a moment. But the main thing tonight, the one that's all the homework's about this week, is strings. So you'll just want to, do some lab time, play around with strings, mess around with manipulating strings and getting familiar with those and all the stuff they can do. And if you have any questions, just let me know. My computer's going to be sitting here with the lights on until 10 o'clock our normal time anyway. It's very much an active subject. We learn by doing, so we want to make sure there's plenty of lab time here in our schedule spot to go do stuff. But otherwise, I'll see you all next week. Everybody have a great weekend.
Yep. See you. Have a good night.
See you, Tom. It happens sometimes, especially with family gatherings. Oh, yeah. So I'm going to go ahead and end here.